Hello friends, welcome to Joy of Life. So before we proceed with this episode, what I would like to tell you is that if you have not seen the system design introduction video, wherein we have discussed about the architecture of this mini project that we are building, I would highly recommend you to check the same. I will leave a link to the description as well so that you can click, check the same and then get back onto the video. In the last video, we have created the Kubernetes inside the Docker container and we have did the setup for our Kubernetes dashboard UI. So today we are going to extend it further. Today what we'll try is we'll try to create some pod deployments, replica set, and we'll try to put one of our service, URL feeder service into the pod and we'll try to access the same. Okay, so before we start, there are few prerequisites. Let's look into those. So let's first check what are the containers that are running, and there are a bunch of containers that are running, and we need Redis and Cassandra in order to access our application. Otherwise, it won't start up. So let's start Redis and also start Cassandra. Okay, as we see both have started, so we'll do some checking. So we'll just do a docker inspect Redis. So we'll first inspect both the containers, Redis and Cassandra, and we'll see that our application is fine. So here is the details. It's running in 172.17.02, and let's verify it. We have Redis running in 172.17.02. We are good over here, and let's check for Cassandra as well. Cassandra is running on 17.03. So yeah, we are good. So what we are going to do next is we are done with the setup. So there is nothing much change. We are not using Kafka. As you have seen earlier also that we have commented the posting to the topic. So we don't need that. So we are good with that. So what we are going to do is we are going to create a container now the same way we used to create, and we are going to push the image to our Docker Hub repository. So currently you can see that we don't have any repository, it's empty. So we are going to create the container and then it will show up in the image, and then we are going to push it to our Docker Hub repository. Okay, so let's go ahead and do that. First we need to build it, and we are going to follow the exact same steps that we used to follow. Like we'll do the Maven clean install, then we'll build the Docker image. And we have discussed this in a lot more details in our previous video. So in case if you are not familiar with this command that I am using over here, please go ahead and check those videos. It will give you a detailed understanding on each one of them. So now we are building the Docker image from the Docker file. So all this command has been discussed in a lot of detail, so you won't find any problem with them. So just go to the previous videos and you can check those. This is an ongoing series. So everything that we do over here has been built from the scratch, and you will face no problem with it. Everything is pretty much covered in the last 20 episodes that we have done. So this is the 21st episode that we are doing over here. Okay, so the image is also kind of ready. So we'll just go ahead and remove any container with the name URL feeder service if it is running, and we are going to build this container from the image we have just created. So we are going to do a docker rm-f URL feeder service. So it will remove any old containers, this high chance. So okay, it was not there. Anyways, that's great. So we are going to create a container, expose our 8085 port where the application is running, and we are going to get it up and running. And once up, what we are going to do is we'll go to Postman and we'll just verify hitting the ping endpoint to see that if it is running as expected or not. So here I have the Postman with me as well, and let the service come up first. So yeah, the service is coming up. I can see the Spring Boot logo, and I can see that it is up running on 8085, and I don't see any problem. Everything looks good. So we are going to go to 8085 and do a ping check. Okay, now it is initialized completely. We are going to do a ping test. So we send a request and we got a pong back. So everything seems good over here. So what I'm going to do is I'm going to come out of this container now, and Let's see if it is still running. And we have our URL feeder service running over here. So the next thing that we are going to do is we are going to do a commit followed by the container ID, which you will get from the container name. So this is our container ID over here. So let me put it, and I'm putting it to my own repository over here. So the name is Joydeep 1982, as you see over here on the right top corner. So what we are going to do is we are going to put this to Joydeep 1982 followed by the name of the service. We'll call it URL feeder service, and we need to provide a tag, and since this is our first commit, so I'm putting it as 1. So once I do this, what will happen is it will create a commit ID, and we can see that using Docker images. So if I do a Docker images now, so you'll be able to see that there is an image called Joydeep 1982 / URL feeder service. The tag is 1 and image ID and things like that. The next thing that you need to do, which is already done for me, is to do a Docker login. So since I am logged in, it won't be a problem for me. But if you are not logged in, it will ask you for your username and password. You can just provide them and you are good to go. So once we are done with this, what we are going to do is we are going to push this image to the Docker Hub repository. So we will do a Docker push, and we already have created this commit, right? So we are going to use the same name, so ID 1982 / URL feeder service :1. So what it will do is basically it will take this image and it will go ahead and put this image into your Docker Hub repository. So even if I delete this image now, it will be available to me. I can do a Docker pull anytime to get this image back from my repository. So it's more like we check in the code, right? So here I am just checking in my Docker image so that I can just refer it, or anybody who wants this image can go ahead and do a Docker pull and get this image from my repository. So even if you want to get this image, you can do that. I'll show you how, and it will be public by default. Though you can create a private one, but I'll leave it public so that you can go ahead and use the same. So it is pushing 55 MB of data. You can see that I'm done with 14 MB. So let this finish. So we are almost there. The image is almost pushed into our repository. So let's go ahead and check in the repository once the push is completed. We think it is done. So most of the things are pushed and are mounted. So we got a ID. That's a SHA basically, SHA of that. So what we'll do is we'll go to Docker Hub and we'll just do a reload of the page to see that if it appears over here. So as you can see that we have this URL feeder service updated a few seconds ago. So, and it is in a public mode. So we can just go ahead and click on it and you will find all the details. And if you want to do update some of the fields with some data, you can do that. You can create a readme file, you can put a description, and here is the command. So you can use the Docker pull for this, and you can use a tag name. So you can't do a latest since I have not said that. And it is pushed a few seconds ago. You can see over here the OS is Linux, and that is the base image that we have used. So you can see everything for this image over here. So everything is available over here, and we need this because what we are going to do is we are going to use Kubernetes, right? In Kubernetes, what we'll do is we'll provide this information. So Kubernetes is going to go ahead and download it. So we'll see that happening very soon. So let's go over to the application and let's set it up. First thing that we'll do is we don't need that image anymore. So if you see that URL feeder service is still running, we are going to stop it. So we'll do a docker ps docker rm-f URL feeder service. So we'll kill this, and we'll just verify that that image is not there, and we will deploy inside Kubernetes. So if you do a docker ps now, there is no URL feeder service. We have our Cassandra and Redis running. So those are the two things that we'll need, and we are not putting them in the container. So let them run. Okay. So before we do anything, what I'll do is I'll open another command prompt window, and what we'll do is we'll set up the proxy so that we can use our dashboard that we have created the other day. So let it run over here. So this will help me to access the dashboard. So here is our dashboard, and you can just do a sign in, the token will still remain there. And what you can see is that whatever pods and things like that, whatever we have, we can do all and see all the pods. So you can see that we don't have any pods of our own. And definitely you can do the same from here as well. So you can do a get ctl kubectl get pod, and you can see all the pods and the jobs from here as well, right? So let me clear the screen. So what I'll do is inside the application we are going to go ahead and create a folder over here where we'll put our Kubernetes things. So let's call it Kubernetes. So the first example that we are going to do is we are going to create a pod YAML file, and we are going to just deploy a single pod. Though it's not recommended, we generally don't do that, but let's try it out, and we'll go step by step. You'll find in the web there are a lot of details how you create a pod. So we are going to use one of this example over here. So we'll use the same thing, API version 1 kind pod and things like that, but we'll keep it very simplified. So what I'll do is let me put things like and the first thing that we'll be needing is the API version, and the API version remains at v1 only. And the kind of deployment that we are creating over here is a pod, so it will also remain the same. And then we need to provide some metadata. So it's a YAML file, so you have to maintain the structure. So we'll put metadata like this. And since we are doing for our URL feeder service, so we'll keep the name and the label both as URL feeder service. So let me put that first. Okay, so name is URL feeder service and label is URL feeder service 2. And label plays a very important role. We'll soon see what we are going to do with that. The next thing that you need to create is a spec. So spec is where you define your containers and what is the resource that you are allocating to it, all the ports, and every detail should come over here. So under spec, what we do is we give the configuration for our containers. So let me put it, make sure you are indenting it correctly, otherwise you will end up having some problem. The first thing that we mention in a container is the name of the container, right? And if you look at our Docker Hub repository, so it is available under my username, which is joydeep1982 slash URL feeder service. And the tag that we are using is a 1. So we need to give the details that what image we are talking about. So we are going to go ahead and mention that the image is joydeep1982 slash URL feeder service and the tag is 1. And we need to also provide that what is the image pull policy. So I'm going to go ahead and say that every time I deploy, you go ahead and pull the image. Don't rely on any stale image or things like that. Next thing is our port. So we need to tell Kubernetes what is the port that's exposed in the container, and for us it's 8085. So the next thing that I'm going to do is I am going to configure some resources over here. So these are the resources that will be allocated to my container over here. So I am telling it that you go ahead and use 256 megabytes and you can use half of the CPU. So basically this means half of a core, right? Generally a CPU is 1000 microcores, and I am giving him 500 microcores. That's half of the CPU. Okay, and if you wanted to see how much has been allocated to your Docker, so you can go to the Docker Hub desktop and open it, and you can go under the resources where you can see that there are 2 CPUs that are allocated. There are 2 cores basically allocated to it, right? You can just check up to the 12 cores are there. So I've just allocated 2 and the memory is 2 GB. So out of these 2 CPUs and 2 gigs of memory, I am allocating this pod with a memory of 256 MB and half of a core, right? And I can define an upper bound so that in case if the memory usage goes high, I can set a limit over here which says that if it exceeds 512 MB or takes a full core, then you are going to kill this pod. So this is how I define my pod over here. I'm going to pull this image, right? So what we need to do is we need to specify it, and we have to provide us a way to pass on my secret. So I cannot put my username and password over here, right? So what I'm going to do is just next to containers, I am going to configure my image pull secrets, and I need to give it a name. So let me name it as Docker Hub secret. So what is this Docker Hub secret and how it is going to go ahead and find it out, right? But what is it and how does kubectl or Kubernetes knows about it, right? So somehow I have to tell Kubernetes as well. I have to configure it as a variable, environment variable kind somehow. So what I'm going to do is I'm going to go over to the command prompt over here, and we are going to go ahead and configure this little secret of ours. So what we'll basically do is we'll do a kubectl, and we are talking about a secret over here. So we'll create a secret for Docker registry, and followed by you have to provide some of the parameters. So one of them being the name of it. So the name is Docker Hub secret. So I'm going to give that name. I have just told Kubernetes that you create a secret in the Docker registry called Docker Hub secret, and now we need to provide him with all the details that he needs, right? So one is a Docker username, and for me it's Joydeep 1982. The next thing is the Docker password, which is going to be my password. Don't look at it. And then you need to also provide it with Docker email, and I'm going to provide my email over here. So once you do that, you can see that your secret has been created. So you are good over here. So secret Docker Hub has been created. So we are done with this. So we are good. We have created our pod file over here. Let's try this out. Let's go to the Kubernetes folder where we have this. And what we are going to do is we are going to use this pod file. So let's verify that we have any pod running or not. So we don't have any pods over here. So we are going to do a kubectl apply, and then we have to give the file name, which in case is pod.yaml, and we are going to give enter. So you can see that the pod has been created. So if you do a get pod now, so you can see that one pod is there and it is in creating mode. You can keep a watch over here, so anything changes you can see it directly. So the pod is in running state now, so the pod is up now, right? So we can send a request to the pods right now, which is running at port 8085. No, the answer is actually no, you can't send it, right? Because the pod is inside Kubernetes and Kubernetes is inside Docker, so there is no way my request is going to get forward to that, right? So the first thing that I need to do over here, even if I try 8085 or 8080, nothing is going to get succeeded over here. So we have one pod running, we can see over here, and let us also verify it from the dashboard that we have spent so much effort on, right? So you can see here that we have the URL feeder service running here. So once you click on it, you can see that it's in a running state, and it has a IP, but there is no way that we are going to go ahead and communicate with this pod. So if you see the logs, you will see the intended Spring Boot logs, everything. So everything has been started properly. You can see over here, right? So what I'm going to do is it's not going to run like this. So it is running inside the container on port 8085. So I have to create a port forwarding, and kubectl provides a way to do that. So you can just create a port forwarding. So you can just say a kubectl port forward, and we are doing it for URL feeder service, and we want all the traffic from 8080 to map to 8085. So currently you have seen over here that 8080 is not responding, right? So but once I create this mapping of port forwarding, so let's create this port forwarding. So you can see over here that 127.0.0.1 is going to port 8080 is going to forward everything to 8085. So now if I go ahead and send a request, and you'll be able to see a pong back. So this is nothing but this is getting served from our container. And even if you try with a post request over here, the one we have created, so let's try that out. I'll go to the body, and I'll try with some website over here, let's say abc.com. And when I try to send this request, you can see that I got a 200 okay. And if you go to the logs now, you should be able to see a lot of data, right? So if you see on the Kubernetes logs from the pod, you can see that abc.com is received over here, and things are going good, right? So you can see that it is running fine, and everything is working as expected, right? So we are good for now. So what we'll do is if I kill this port forwarding, if I do a control C, and kill this port forwarding over here, then you won't be able to send any more requests, of course, and you will hit a 404 kind of things over here. So let's change it to get, and if I just put it to ping now, since I have killed it just behind this window, you can see, so it will get a error, connection error over here, and you won't be able to succeed. But do keep in mind that our pod is still running, so it's running and up and healthy. From 4 minutes 42 seconds ago, it's running fine. So now we are going to go ahead and kill this. With creating a single pod is that you don't know when to how many pods to mention, if you need more pods or not, and if you wanted to maintain suppose 3 or 4 pods. Let's say if you have to maintain 3 pods, so you just can't come over here and check it manually again and again. So what if one of the pod crashes or anything happens, right? It's not possible for you to do the same thing again and again. So that's why we use a replica set in that case. So I'll go ahead and delete this pod over here. So you can just do a kubectl delete pod followed by your pod name. So you'll be able to delete the pod. So it will take some time to delete. It does a graceful shutdown, and then it will delete the pod for you. So it will take some time, few seconds of time. And if I do a kubectl get pod, so you'll see that there are no pods over here, right? So let me get rid of this what. So there are no pods, we have killed it, right? And that brings us to the next part of this tutorial over here, which we just talked about, is a replica set. So we are going to create a replica set and name it replicaset.yaml file, and we are going to create this YAML file. So this YAML file is not going to be much different than what we have just created. So it's pretty much the same, but it will have the replica set details along with the pod details. So we have just seen the pod. So let's go ahead and check the replica set. So the only few thing that I am going to introduce over here is API version. Once again, you will get all these details inside your inside the Kubernetes docs. So since I have them, I'm not going there again and again, but you will find all these details present inside your Kubernetes documentation over here. So let's go ahead and create it. So APS v1 is the API that we are going to use, and the kind of deployment this time will be a replica set instead of a single pod, right? And each of these will come with a metadata, and you need to provide it with the name. So we'll provide the name as URL feeder service, the same name. And once again, we have the label. So we'll come to the labels in a short while. Under this label, we'll use a different name over here. URL service RS stands for replica set. So URL feeder service -rs, that's the replica set over here. And we need to provide a spec, and this spec that we are providing over here is for this replica set. So we'll say that we'll need 3 replicas, let's say. So it has to ensure that 3 replicas are running over here, and we need and we specify a selector over here. This selector is something very important for us to know, and this has something to do with the labels. So I am going to say that okay, you create a selector based on the labels. Label name should match the label of the pod that we are creating, right? So replica set is a collection of pod, right? And here I am saying the collection is of the size 3, and how it should know that it's maintaining the right number of collectors or not. So we are going to give a name over here, URL feeder service app, right? So now we'll see where we are going to match this, and we are going to provide a template. So this template is nothing but the spec file that we have created for the pod, right? So this will be that pod template, the same thing that we have created over here. So this pod YAML that we have created over here will be used as a template over here, right? So we are going to put that in the metadata part, and we are going to give it a label as well. And this label should match this level, right? The template should be of this level. So you are telling that match the level of the template that I am providing you, and they should be same, and there should be 3 such labels. If you don't find 3, just go ahead and create one more, right? So we have this over here. So the next thing that we need to provide is the spec. So the spec is nothing but the spec that we have created earlier. So we are going to copy the entire spec, this container part, from this guy, and we are going to put this over here, right? And again, at the end, what you need to give for this container is you need to provide the secret that we have created, that image pool secret. So we are going to take this and we are going to put it over here. So we have created a replica set inside it. So let's go ahead and try it. So now that we have our YAML file ready for the replica set, we are going to go ahead and create it. So what we are going to do is we are going to do a kubectl apply f. I don't know my memory is going to support this or not, but let's give it a try. So we have the replica set YAML file. So we can see that it's created. So let's go ahead and watch it. So container creating, two are in container creating mode, the other is in pending state. And as you know that I have a memory of 2 gigs, and I'm not sure it will be able to create all three or not, though we could see two are in running. And let's see if it is able to create the third one or not, because apart from this also there are a lot of containers that's running for Kubernetes in Docker, and we are just using a single system. So this we are doing basically for your understanding purpose, right? So let's see the pods over here. So you can see that we have two pods in running condition. One is still struggling over here, so which is not up yet. So let's see what's in the log of this. The selected container has not logged any messages, so it was not able to start it yet. Yeah, it's pretty much struggling. You can say that two are up and the third one is struggling. So what we'll do is we'll try to increase the memory and then give it a go. So I'll put it as 5 CPUs or 6 CPUs, and give it 8 gigs of RAM, and then let's see if it can do it. So again, I do have to do a apply and restart. So let it happen. So it will stop your Docker and nothing will work for now. So it will kill everything that was going on. So let me stop them as well. Okay, I think both have started, both are running. So let's do a Docker ps and see. Yep, we are good. So let's go ahead and check what are the pods running, and we can see that both has crashed over here. So what we are going to do is we are going to go ahead and delete it, and what will happen is it will keep so it's a replica set, right? So it will keep trying to create it. So you'll be able to see the status changing over here. So you can see that since I have told him to maintain 3 pods, so he's continuously trying to create the new pod whenever it is failing, right? So let's open another command prompt and do a kubectl proxy so that we can connect to our dashboard so that we can get more details. We have all the 3 pods running now. They were facing some problem initially, but they are fine now. So that's the advantage that replica sets bring over here. So if I show you now, if I do a Docker get pods and bots, so you have 3 pods running over here, right? And the beauty is that Kubernetes is going to go ahead and maintain this. So let me open a command prompt over here quickly for you. And what I'm going to do is we are going to delete a pod from here. So we are going to do kubectl delete pod, and we are going to give this a pod name over here. So we are killing this guy over here. So the moment I go ahead and kill this guy, so this condition over here, 3 replicas of this type will not be valid anymore, right? And kubectl will realize that fast, and he's going to spin up a new pod for me. So the moment I kill this, so you can see terminating, pending, container creating, he's creating a new pod. So the moment one pod crashes, the replica set makes sure that another pod comes and takes it up, and it's going to keep trying it until there are 3 running pods, right? Since I have mentioned to him that I need 3 running pods, so he is ensuring that it must happen. Okay, so this is about replica set and about the pods. Okay, the next thing that we are going to take a look at is a service. So we are going to create a service.yaml file over here. The lowest level in Kubernetes is our pods, and then we have the replica set on top of it, and on top of it we have the deployment. So we'll see deployment soon. And apart from that, we need to create a service. So this service is a gateway from where we are going to talk to this application, right? So we have it in the container. We did a port forwarding on one of the container, and we got things up and running, but that's not the way to do it. So once again, it is very similar how we create a service. So API version is v1 kind is a service, and then we have the metadata, and we provide a name, and we provide a name. So let's not call it web. We'll call it URL feeder service web. So let this be the name over here. The next thing that we need to do over here is to specify the spec for the service. So again, the spec will include the kind of service that we are creating. So we are creating a service of the cluster IP type, and we need to give a selector that we have created this cluster IP type service. That's fine. This service is for which all pods that are running. So we need to give a selector over here. So if you remember that we have used the same name, so let's go back to our replica set and check it. So we have given the name as URL feeder service web, as you see over here, and we are going to use the same name over here. Okay, why do I get it over here? Okay, so we have provided the selector over here, and the next thing that we need to provide is the ports. So we have to map these ports over here. So the protocol that we are going to use is TCP. And we are going to map 8085 to our target port. Of 8080. So basically we have the target port and this set over here, so we are good. So let's go back to the terminal, and over here in the terminal, if I do a kubectl get all, kubectl get all, you can see what all is running. So we have 3 pods running over here. There is one service for Kubernetes that's running, and we have one replica set running, which is having the desired and current number of containers. So what we are going to do is we are going to apply the service that we have just created, and you can see that the service has been created. So if I do a kubectl get all now, you should be able to see that we have 2 services now right over here. So this is the service that we have just created. I think I did a reverse. Okay, so let me go ahead and kubectl delete service slash URL feeder service web, and now I'm going to start it again, and I'm going to get all, and yeah, it's mapped to 8080. It's okay now. So I have an IP address over here now, and what I need to do is I need to set the port forwarding to the service this time, not to the pod like we have did last time. So what we'll do is we'll use the same command all over again. So kubectl port forward, and we are going to do to the service, and the name of our service is URL feeder service web. So this is nothing but this name over here, and we are going to say that we are going to forward all 8080 to 8085. Let's go ahead and okay, kubectl, not kubectl. Okay, so our service is also running at 8080 and it's mapped to 8085 internally, right? So we are so you can see over here that all 8080 is going to get forwarded to 8085 inside the container. So we have to specify 8080 since our service has a target port which is exposed at 8080, right? So this is the port, and internally it is mapped to the 8085. So we are good over here. So what we'll do is we'll just do some ping test over here, and you can see that we got a pong. So what if I send multiple requests? What do you think? It's doing a load balancing for us because we have 3 replica set. Actually no, because we don't have a load balancer service over there. What it's doing is it's getting all the pods and it is sending to the first one. Since in ping we are not doing anything, so let's do something. We'll do a post to our endpoint wherein we'll have some logs. So let's do a post over here, and let's send a couple of requests. 200 okay, 200 okay, 200 okay. I've done some 4-5 requests over here, right? And now if it would have been load balancing, then we would have seen it in all the pod logs. So let's see, let's start from this one over here. So I'll go to the logs, and I can see that the request has landed up over here. So you can see that all abc.com has landed up over here. So this is the first pod that we have seen. Now let's go to the second pod. There is no request over here. Let's go to the first pod. So we'll see the logs. There is no request here. So you can see that it's not really doing a load balancing here because it was not meant for that, right? So all the requests has landed to only one service over here. Okay, so this is how a service works, right? So we have just configured a service to get a virtual IP address, and we did a port forwarding, and that's all, right? We have never talked about a load balancing thing over here. In upcoming videos, we'll see how we can get the load balancer also up and running. We'll not go into there for the moment. And with that, the last thing that I want to cover for you guys is a deployment. So what a deployment is. So we have seen pod and we have replica set on top of it, right? And on top of replica set, what we have is something called a deployment. So if you see this example, what we have done is we have created a service, we have created a replica set, but we should not do it separately. So we can get that done in a single YAML file itself. So we have a dependency, right? We should have the replica set, then only we can have this service, right? So to get all those things up and done within a single thing, we can do it using a deployment. So first let me go ahead and delete the replica set. So we are going to delete everything that we have created so far. So we'll go ahead and delete the replica set and the pod that we have created. So it's gone. We have not created the pod, we have created using the replica set, and we have created this service, right? So kubectl delete, I'll do of this also, kubectl delete followed by this is also gone. So let's clear the screen and let's see what all we are left with. So you can see that we don't have anything. So we have just kubectl's own Kubernetes service, and we are not going to touch that. So instead what we'll do is we'll create a deployment over here. So we'll specify the app version and the kind, and then again we have to give the metadata over here. So in the metadata part, we'll give a name, and we will call as URL feeder service deployment set. We just use the name, and we'll give some labels, and let's use the same thing as label. So in the label we'll always use app, so we'll keep it as app, and we will give the spec over here, and in the spec we'll mention the replicas that we need. So we need 3 replicas, and we need to provide the selector for them as well, and we'll say that you should match the labels, and the label is nothing but the name from here, URL service web. And again, we need to provide the template for it. So the template is nothing but what we have done over here. So let's go ahead and get the template. Okay, I doubt the formatting, but this is how it looks, and so we have specified everything over here. So nothing much special over here. Same, the replica 3, the match labels, and then we have the template, right? We just the same thing that we have done for the replica set, so we have done for the deployment as well. But the advantage with deployment is you can specify multiple resources. You can just put 3 dashes, and you can see that it has changed to document 2 of 2. And what we'll do is we'll copy the same service that we have created over here. The same service, we are just going to take this and we are going to paste it over here. So again, API version v1 kind service, the same thing. So we have multiple resources inside one single deployment file. So that's all, that's nothing special. So here we just go ahead and specify multiple things. So let's go back to the terminal and let's try it out. And what we'll do is we'll try to get this up and see that if it works. So there has been some indenting issues as always, so let's fix that, and let's go ahead and try it. Oh god, again with the template. Last time it was with Spec, so let me fix it and then run it. So yep, this time it's been created properly. You can see that the service and deployment both has been created. Now if I do a get all, you'll see that we have 3 of the pods, 1 replica set, 1 service. It's all created. And what we just need to do is we just need to set up this proxy that we have did last time, and we can get things up and running. So if I just go ahead and do so I think handling connection, so it's yeah, it's up. You can see that let's try with xyz.com, and you will see that it's still working, and all our requests will mostly go into one service, as you have seen earlier that one as well. So these are the 3 pods, URL, feeder, service, dep. So it is part of this deployment. So we can just go ahead and see the logs as we have done earlier. So once again, it's not doing any load balancing, and we are going to see that in a later video. So in this video, I think we have pretty much covered all aspect of it, like the smallest unit pod, then the replica set, then the deployment, and how to use the service in order to get things up and running, right? So this video got already long, and I don't want to keep dragging it any further. So I hope you got a fair idea of how things are working. So let me know if you have any questions with the pod, replica set, deployment, or the service that we have discussed over here, and I got you got a fair understanding of how things are working as well. So with that, I'll end the video. So stay subscribed, and do refer to your friends, let the channel grow, and please let me know if there are any topics that you want me to cover. I'll be more than happy to give it a try to create a video on that. With Kubernetes covered now, what we'll do is we'll try to see how we can do load balancing in Kubernetes in some later video, not the next one probably. And down the line for this series, I have several other plans like using Mongo, going deep in Cassandra, and figuring out many other things using Elasticsearch and things like that. I have a lot on mind, because that is something very important for us to know as a developer. So I am not going very deep. I am keeping it at a very high level that a developer should know. So I am not going to the DevOps level and seeing all those internals, but I am giving a fair idea of how to deal with things when you face a problem, right? How to get a pod logs and how to find it out and things like that, right? So with that, I will not drag the video any further. So I'll leave that I'll leave it to you guys to ask me any questions or any things that you have in mind in the comment section below. So take care, bye bye, and stay subscribed, and refer this to your friends as well. Let the channel grow, and bye bye.